Good. So we are looking at medical genetics today on chromosomal banding and then their nomenclature. Good. First of all, what is chromosomal banding? Now, chromosomal banding refers to the alternating light and dark bands along the length of chromosomes produced after staining with a dye. And if you look at your karyotypes, you'd probably find a lot of them. If you watch, a video on karyotyping, you would find the dark and then the light bands in them. And the banding can be studied best at metaphase. And so chromosomal banding is usually done on our chromosomes at metaphase, where we arrest the cells at metaphase using a chemical colchicine. Okay, so we use this chemical colchicine to arrest the cells at metaphase, and we do that because at metaphase we have highly condensed chromosomes, and these highly condensed chromosomes would give us high contrast. Okay, good. Now we have different forms of staining techniques that I've arranged in this diagram. We have the gene banding, which uses the germ cell dye. That is why we call it the gene banding. First, you lyse the protein with trypsin, and then you stain the protein with your dye, with your germ cell dye, and you would find the dark and the light regions. Now, the light region represents an area that is rich in adenine and then thymine bases, nitrogenous bases, and then your light bands is rich in guanine and then cytosine bases. So understandable. But we see that using germ cell dye, if you see a dark band, it doesn't only represent the adenine and then thymine rich centers. It also constitutes that you have heterochromatin that is late replicating. What is heterochromatin? Heterochromatin are genetically inactive form of your chromosomes. Let me put it that way for you to understand, because they are condensed. Okay, yes, they can be permanently or temporarily condensed, and the euchromatin are the active form of your chromosomes, something like that. And then we also have your R banding. R banding, you do heat denaturation and then you stain with a germ cell dye. And then it is the reverse of your germ cell staining or your gene banding. That is why we say R for the reverse of the G. So this is a reverse banding. And because it's a reverse banding, the euchromatin would represent the dark band, which is rich in, which would be rich in guanine and then cytosine, and then the heterochromatin rich in adenine and thymine would be for the light band. We also have Q banding, which is the quinagrin banding. Quinagrin is a stain. We have a dye or a stain like that. So this one, you don't do anything with, you just stain with the quinagrin master dye, and it's able to stain and stain well. And then you are able to see the dark bands. Anytime you see the dark band, it's just equivalent to the gene banding. It's the heterochromatin late replicating dark bands, rich in adenine and thymine. And then you have the light bands, which are guanine and cytosine rich. Good. We also have, what do we call it? A C banding. In our C banding, we do denaturation with your barium hydroxide, and once you do the what do you call it, the staining or the denaturation with the barium hydroxide, you would get dark bands. You would get some dark bands, and these dark bands usually represent your constitutive heterochromatin. Now, your constitutive heterochromatin are the permanently inactive form of chromosomes or condensed form of your chromosomes. So that is that. It is specifically used to look for constitutive heterochromatin within a chromosome. Good. And then we have the null banding. The null banding, you do pre-warming with ethanol, and then you wash with formic solution, which can be formaldehyde, and then you stain with silver nitrate. After that, the regions that you will see are your null, which is your nucleolar areolar region. So this banding is specifically used to look for your nucleolar areolar regions. And this can only be found in acrocentric chromosomes, okay? Acrocentric. So if you've watched the video on, what do we call it? The banding, sorry, your karyotype, and you realize that that is group E and then group G. Those are acrocentric. They contain the nucleolar areolar regions, nucleolar organizer regions. I've been confusing you, sorry. And then we will just look at a brief nomenclature of your chromosomes. Now with chromosomes, you can see something like 7q11.2, something like that. Now, what the 7 represents is that it represents the chromosome number. So 7 is for chromosome 7. That is the chromosome number 7, chromosome 7. The Q represents the arm, which is the long arm. First of all, let me bring you here. If you look at these two arms of chromosomes, you can see the down one is the tallest, and so it is known as the Q. Represent a queue that we form. You see, we can form long queues when we want to take buses to places. So that is a queue. And then this short region is known as P for the French word petite, which means young, little, or short, something like that. I'm not a French master, but I know that that's what it means. Good. And so if you have something like this, the first digit that follows the alphabet represents a region. This represents a region. And then the second number that follows represents a band, what we've been looking at. And then after the dot, what comes is the sub-band. As to understanding how to label these ones, we cannot do that here, but we'll try and explain so that anytime you get a chromosome number and then you have an aberration at a specific point, you can interpret when you have you are presented with a lab report like that. So if you look here, you can see we have 21.12, which means that on the long arm, which is the Q arm of chromosome 7, region 2, band 1, sub-band 1, sub-band 2, there is something there. In cases where you have, this is an example, FTR, which is the cystic fibrosis regulator, transmembrane regulator. It's on the chromosome location is 7q31.1. It means that .2, which means that on chromosome 7, on the long arm of chromosome 7, the third region, band 1, sub-band 2, you understand? And if it's a telomere, if it's the last portion or the tip of a chromosome, then we represent it with a tel, so tel. So you can have something like 7q tel, which means that the telomere of the long arm of chromosome 7. So that is a little thing that you can know for now in medical genetics, and it will help you in your exams, in your in your practicals, and then in your clinical setting. Thank you very much for watching. Don't forget to subscribe. Don't forget to tell other people about StudyPort. Enjoy the rest of your day. Bye.